we're continuing here with some extra questions involving sine, cos, and tangent, and Pythagorean theorem in some combination thereof. And we're going to look at compound triangles. We'll do 3 questions out of the remaining 5 questions in the chapter review questions here. We'll do questions 8, 9, and I believe the last one we'll do is 11. And then after that, we're done the chapter. With the remaining time, we could take a look at some more material, and then we can potentially jump into chapter 6 a bit. I might do a question from chapter 6 also. I'll go easy on you because I've heard from your classmates that you have a heavy load of exams today. So anyway, here we go. So here's a compound triangle situation, and what you notice is that the diagram looks like you have a right-angled triangle and a triangle that's not right-angled. But I'm going to try to use right-angled trigonometry for all these questions. For those of you that are familiar with sine and cosine law, you can use those approaches, and that actually might simplify some of the questions. But I'm doing it this way because I'm trying to just stick to sine, cos, and tan. So anyway, the first thing you want to do here, you're trying to solve for the quantities x, y, and z, x being the length and y and z being angles. The first thing I would recommend you do is draw 2 separate triangles. So you can draw the one triangle here, that's the smaller triangle, and then you can draw the other triangle here beside it, that's the larger triangle, and I'm just going to emphasize that it's much larger. And that would help you, that's the worst triangle. And that would help you work out the question. So using information from the question here, that's 6.87. This is 16.11, sorry, should say it correctly there. This is 37 degrees. And some more things. This is y. What else? X is not really explicitly on this diagram. I'm going to call this A and this B. And then on the side here, I'll tell you that x is equal to b minus a. So this value x here is indirectly found by getting a and b. You subtract the length of the large triangle and the small triangle. Finally, it would be useful to just label one more thing here, which is theta. I'm going to call this angle here theta. And I think from there we're good to go. Can someone tell me this angle up here? Just quickly, what's that angle right there? What's that angle there? Anybody have that? Yeah, that's right. It's the 180 rule. Thank you, Shalon. Or you can do 90 if you want. 37, so that'd be 53. I'm going to write that in purple. I know that it's not, I like to write the original things in purple, but that's such an easy number to get. I'm just going to drop that on the figure and call it as I see there, okay? So now I'm going to also write one more thing down here. So y is right on the figure, so that's good news. X we're going to find indirectly. The only other variable in here to look for is z. Z can be found eventually by doing theta minus 53. So there's all the building blocks that you need to do this question. So at this point, I'm just going to switch to my keyboard and draw a little bit less because it sometimes lags. So let's shrink these diagrams down a little bit. So you've had me enough times now with SOHCAHTOA where I label the triangle, opposite, adjacent, etc., and the hypotenuse. So now what I'm going to do is just strictly write down the math and not label the triangle. So in no particular order, you could get each of the quantities here, which are theta, b, y, and a. It doesn't matter where you start, it doesn't matter where you finish, just do what you can. So I'm looking here, and I'm trying to get something useful, and I'm hoping that there's something else that I might have missed, because this triangle looks a little bit empty. And I just realized here that we could put 6.87. So that's a common side. that's shared by the two triangles. So now I'm satisfied that we can solve for things that we need to get. Because here we have at least two numbers other than the right angle, and here we have at least two numbers other than the right angle. So we have enough information that we can just fill in the image here with the quantities. So let's get A here. In order to get A, we could use SOHCAHTOA. Now, it doesn't matter which way you go. So I'm going to use 37. I'll use 37 just because it's the first number I saw, and it was the most original number in the question. So let's do that. So that'd be tan of 37 is equal to 6.87 over A. Just take a moment and think about what I did there. I don't really need the top figure. I'm going to scroll it down a little bit here, because all we're working on is these two purple triangles now. So A is here, and 6.87 is there. Remember, I chose 37 as my angle. Thank you very much. Okay, Denny, you are the benchmark today, my friend. Yeah, you could use 37 or 53. If you use 53, then you don't have to divide. But you know what? By the time that you waste to choose, you might as well just do something useful and it doesn't matter what you use. So I don't really, think too hard about that. I just pick one of them and go for it. I already did these calculations on my own, so if you don't mind, I'm not going to worry about that. Just you confirm it on your calculator in case I made a mistake on my side calculations. Okay. I gotta close and reopen the file for a second. Sorry. Sometimes PowerPoint does that to me. Anyway, okay. So we got A down here. That's great. Now we're gonna go to this triangle and we're gonna start solving for other quantities. You could solve for B. For B, you could use the Pythagorean theorem. See, the Pythagorean theorem is not a cast out, right? Like outcast, sorry, the word is. You can still use it. So eventually, I got 14.57 meters. Okay. As I'm doing these calculations, I hope that you're in the background doing the same calculations and confirming that you agree with me that the numbers are correct. We need one more thing here. We need theta and y either. Thank you, Shalon. So sorry, you need either theta or y. Once you get one of these, the other two is easy to get because of the 180-degree rule. I'll get theta. So I'll use cos theta. I could use cos or sine or tan. Well, actually, I could use cos or tan, but not sine. But because, well, I guess I'm trying to avoid the letter B here. That's what I'm trying to say. Because B is not, B potentially, what if you did it wrong? Then you might like propagate some error there or rounding error. Okay, anyway, so that's that. Okay, so I did that. And eventually, I got theta is 64.8 degrees. All right, so once you have theta, then the question is almost done. So far on the original diagram, we haven't solved for x, y, or z. So it seems like we're kind of hopeless right now. But don't worry, my friends, we're in the home stretch now. Here's the rest of the answer to the question. So let's get y first. So y is equal to 90 minus theta. So that's y equals 90 minus 64.8 degrees. So y equals, anybody have y there? I didn't write y down on my answer. That's hilarious. 25.2. Can someone confirm? Everybody okay there? It's very quiet. Thank you, Shalon. Okay, let's get x next. So x equals b minus a. That's from up here. I'm just recycling my little instructions up there. X equals 14.57 minus a, which is 9.12. So x equals, wait for it, x equals 5.45. And finally, we need z. So z is equal to theta minus 53 degrees. So that's theta we had earlier is 64.8. It is a lot of work, but is it difficult? Ask yourself, it's a lot of work, but is it difficult? And if the answer is it's just a lot of work, then don't worry about it, my friend, because I'll take that over something that is more creative. Yeah. So this is like brute force type of math. Just pushing through the question like you're running to the finish line. Whoops. There we go. I have to close and reopen PowerPoint because it's not allowing me to select. So just a second, okay? All right. Definitely a marathon of a question. But when you look at it, you can see that it's a question that you could break down into pieces and you could deal with separately. This question does not necessarily require SOHCAHTOA for. Like this part here, you could use the sine and cosine law and do some stuff. However, I'm just sticking to the right angle triangles. So the penalty that we pay for doing it this way is that it's a little bit more writing, but the benefit is that it's less difficult per step because all you're doing is literally just SOHCAHTOA Pythagorean. And I know most people would agree with me. SOHCAHTOA Pythagorean theorem combinations are less likely, or sorry, are easier to use than cosine law, especially, and sine law. But some people just want to use sine and cosine law. It's all good. I don't care what you use as long as you get the right answer. I just care that you get it correct. So we're going to do one more question with these compound triangles. And then we're going to do a third question to complete the chapter. So let's take a look here at this one. So the question here is to find the angle theta. You see theta up there? We're trying to find theta accurate to the nearest minute. So that's looking a little bit gross because it's this type of question you kind of work through. Yeah. You got to work through the question. My friends, I'm not going to draw this one this time. I'm going to just use my I'm going to use my little software here. I'll edit this out later anyway, you know me. I like to edit the videos before I put them online so that they look somewhat pretty. Nah, it's okay. So what I'm going to do is I'm going to take this diagram and I'm going to break it into pieces like a little jigsaw puzzle. So here they come. Here's the first piece. Here's the second piece, and here's the third piece. It's not to scale, but you have to appreciate the fact that I'm trying to kind of clean it up a little bit here. Let me just dump out some of this crap here. Dump out some of that over there. We don't need the letter E there. Good enough, eh? Are you happy with my picture? Because there's no refunds. This is the best you get from me. Yeah, once you separate it, it's just divide and conquer. So if this was like you and a friend working on a project, like we could number the triangles and go from there. which is exactly what I'm going to do. I'm going to call this triangle number 1. I'll call this triangle number 2, and I'll call this triangle number 3. So our goal is to get theta right here. But the problem is that we only have one number and the right angle. We need another number. There is no hope of us getting this number. We cannot do this. There's no number there. We cannot tell that length. There's not enough information. However, if we call this A and we call this B, those heights, then this here, which I'll call H, is easy to find because H equals A plus B. So once you have H, then you're good to go. And that's it. That's exactly it, people. Step 1, get A. Now we're not going to say get, I'm just going to solve for A. And then step 2, I'm going to solve for B. And then step 3, I'll go down here and finish up. So let's get that keyboard out and work some magic. So looking at this triangle here, that's SOHCAHTOA. And you notice that you have opposite and hypotenuse. So that's sine. So sine of 28. So A equals, this is a multiplication question. So I got earlier when I did this, 2.9952 meters. Now, you don't need all those digits, but I'm being very careful because the question asked for the angle here to a very accurate minute, to the nearest minute. So I want to be careful that I don't put like here 3, for example. If you just wrote 3 here, that's pretty bad. You need to keep a little bit extra, you know, don't be too cheap. I'm not accusing you of being cheap, just in this question. So over here, let's do the same thing with 21. We'll take 21. It's also another sine, so that's cool. So I like repetition. Repetition's easy to work with. So that's B over, 9.112. Yeah, 4 decimals is more than enough here, yeah. It's better if I space them, I think, right? Now, some people in science would argue that I'm putting 4 decimals here when I only have, I'm putting 5 significant figures when I only have 4 here and 2. I'm not doing this the way you would do it in science class. I'm just assuming that these original numbers are accurate beyond just what's presented. So anyway, A is equal to that. Oh, this is B, sorry, my apologies. So that's B. So I got B equals 3.2654. So there you go. That's the first part of the question. We got that out of the way. And now we're in a lovely position to finish off the question here on the left. Not that you need to number these, but maybe if it helps you, I will number them. So we're doing this first, then we're doing this second, and now we're going down here to finish the question. So I'm just numbering them again here just so that it's crystal clear for everybody what's happening. So let's scroll down just enough so you can have it on your screen at home. And let's get H here. So this is like the easy step. H equals A plus B. So 2.9952 plus, so I got H is equal to, what'd you get? 6.2606. I scribbled this on a piece of paper, so hopefully I did it right. Looks right. Okay. Okay, so now that you have H, your turn. Which trigonometric ratio would be useful here to get theta? So maybe one time today at least I'll show you again. Here's theta. Remember, this side here is the opposite, and this side is the adjacent. So if we write SOHCAHTOA, which of these 3 is it? Which one is it, people? Yeah, it's tan. Okay. Am I having just a conversation with Shalon? Is everybody else worried about their test? This is hilarious. Or have you delegated Shalon as your spokesperson? I like that. Shalon, you're the official spokesperson of section 47502. I'm glad you're listening, Amira. I appreciate the participation. Yeah, I'm smiling here. I have the video feed off, but I'm smiling, I promise you. You're most welcome. So let's get theta here. So theta is going to be found by using tan. So that's correct. Good point. So theta is 3.875 over h, which we now know, 6.2606. So theta is equal to tan inverse of that stuff. Zifeng, thank you for hopping in there, my friend. That's what I'm talking about. Making my day a little bit more pleasant. I appreciate it. So yeah, 31.76. Don't get too mad at me. I'm going to put a little bit extra, okay? I'm not being a baby here. I'm putting a little bit extra. And then remember that the question is asking for to the nearest minute. Remember that? It says to the nearest minute. So the final answer for this question, at least, I got 31 degrees and 45 minutes. Beautiful. And there you have it, my friends. Look at that. A scary little question. That's right. 0.755 times 60 is 45. So for those that are wondering, how did I get the 45? I've hit you enough times with this on your assignments that I hope it's second nature to you by now. So yeah, anyway, just take a second and digest that, and I'm gonna have a sip of my coffee here. Reload the vocal cords for the next round. Oh yeah, this one here is actually, it's decaf. This is actually interesting. I've cut the caffeine for a little while. This is it's decaf coffee with cocoa, pure cocoa in it, and it tastes amazing. I don't know if you like that, if that suits anybody here, but it tastes amazing. You know what? If I was in Greece right now, I'd be having an orange juice myself. But we're up here in the snow right now, so I can't feel the orange juice like you. Let's take a look. Oh yeah, okay, so let's do this question here. This is a question involving compound triangles, and we're asked to find a whole bunch of stuff here. Now, I don't know about you, but when I see this question, I just get overwhelmed by the alphabet because there's A, B, C, D's, and all this kind of business, right? You kind of see what I'm saying here? Like when you see this A, B, B, C, B, D, honestly, that stuff just bugs me. Yes, definitely is good for health, Jifang. Yes, I do love my tea. I do love my tea. What? Okay, I'm going to tell you the honest truth on this one. The way that I solve this question, and you're going to laugh at me, but it's true, is I don't look at this. I don't look at that at all. When I see A, B, C, B, D, D's, I'm getting all kinds of confusion, and I don't want to waste my time with that. So this is what I do to solve the question. I'm going to take this picture here and just shrink it a bit. And instead of that diagram, I'm going to draw two separate triangles. Again, like I did earlier, I'll draw a big triangle. I'll draw the big triangle right here. And I'll draw a little triangle right here. Maybe not that little. Just bear with me while I write down some information here that's pretty obvious. So I'm going to ask you to help me figure out all these things. We're going to call this here X, H, B, and this is also H. And I bet you that if we can get all these things that I've written here, that we'll probably answer everything in the question. So let's solve for all of these quantities and see if it actually reveals what we need for the question. In addition, Yeah, exactly. I would just find all the lengths of the sides and then if I, you know what, if I waste a little bit of time, who cares? Exactly. Find all the stuff and then sort it out later. I use this approach when I'm under pressure. When I'm under pressure, the time that I waste trying to navigate the best possible way, because there is a best possible way, the time that I waste to find the best possible way is offset by the time I can use to just brute force the whole question. So we're going to go and find all these quantities now, and I'll just do it systematically using SOHCAHTOA. So without any priority here, I'll just get x first because it's the first letter that I drew, and then go from there. So I'll use the 32-degree angle because that's original to the diagram. So cos of 32 is equal to 150 over x, which means that x is equal to 150 over cos 32. How did I get 58 and 42? I used the 180-degree rule. I got these ones in pink using the 180-degree rule. You'll see me do that on occasion now. It's like, if it's like 180 degrees, I just drop the number on the picture. So eventually, you get x is equal to, I got 176.88. This is not minutes, this is feet. Don't confuse that with minutes. So that's great, we got x. You can get h using the Pythagorean theorem, but my preference is to use the most original information on the diagram. Or you can use, honestly, you can do whatever you like. I'm not going to pick on anybody here. So I'll use sine. I'll just use sine. Like, if I wanted to do it the best possible way, I should use tan. So maybe I'll use tan then. Don't mind me flip-flopping. I'm just trying to be a good example for you, that's all. A good role model. I'm not a flip-flopper. I make a decision and I stick to it. Okay, 150 tan 32. Can someone confirm their answer? I got 93 point something. Did you guys get something like that too? Please let me know. Thank you. Sweet. Thank you, Zifeng. Okay, so that's good news. So now that we know what h is, we can actually recycle that on this side. So I'll just draw it in green here. We know that this number here, this height, is 93.73. Whoops. So we're in a fantastic position now to finish off the question. And I think from there we should be good. I noticed that I didn't label one thing, but I'll deal with it later. It's fine. I have some of my own notes on the side here that I'm using as a reference, and it's probably not necessary right now. It's fine. Okay. Anyway, let's get B. Isn't it tan 32 150? Yeah, that's what I have. It's easier to put the 150 in front just because on some calculators it's weird. Is that what you're asking, Denny? It doesn't matter, no. It's easier to put it in front. They're multiplied. These things are multiplied. So it doesn't matter which way you write it. How does the h on the same side with a 90-degree angle? Isn't it supposed to be opposite to the 90 angle? This is not, Shalon, this is not hypotenuse. This is the variable h. Yeah, these are multiplied, Denny, these are multiplied. This letter h here, it's okay. This letter h, people, if you're getting confused, this is not h. That's the height. If you want, let's make our life a little bit easier here and call that y. Let's call it y. I'm just going to rename the letter y, okay? It's all good, people. There we go. Okay, so back here now we have tan of 48 is equal to 93.73 over b. So b is equal to, in this case, Denny, to your comment, in this case we're going to divide them. And so the order does matter here. Here the order when they're multiplied doesn't matter, but here it definitely, the division has the length on the top. What's the difference here? Are you referring to this part? The difference is because here the variable is on top, and here the variable is on the bottom. When the variable is on top, the pattern that we explored last week was that they multiply, and when the variable here is on the bottom, then you do a little switcheroo trick that I taught you, that you just switch these guys here, the tan and the b, and that saves you a little bit of algebra. So eventually you get 84.40 feet. Awesome. So let's go back to the question now and see what the heck is going on here, because honestly, the question's good. I feel confident, but I'm just annoyed by all the letters. So I'm going to go over here and make a list. AB, AC, BD, whoops, and CD. Now, because I have 14 other people here that are with me to help, you're going to help me figure out how to decode this mess. So AB, AB, do we have AB? Let me know. You're the boss here now, people. Do we have AB? What is it? It's 93.73. That's right. According to our figure, I labeled it as y. I'm just putting the variable that we use together, just so that you have a reference to the diagrams below. What the heck is AC? AC is, yeah, that's right. It's x, which is 176.88 feet. BD. BD. Well, this is cute. It's little b. How convenient. Little b is 84.40. And finally, CD, we didn't explicitly make a variable for CD, but you can find it by doing this. You can just take 150, which is the whole length here, and take away b, which is this little length here. And when you do that, you're going to get 60 something. 65, 60. And there you have it, my friends. That concludes the chapter. Easy peasy. Anyway, those are the questions I wanted to cover with you. With 100% certainty, I wanted to get those done. Now that we've completed them, I feel confident in the lessons that we've had, and I think that we can go and look at chapter 6 a little bit.